Right. Okay. So yes, welcome to class this morning, everyone. And for our class last week, we did a lot of things. I know it was overwhelming a bit, and we talked a bit about, or we talked much about modules in Rust, and from there we were able to see different use case of Rust in terms of how similar or how much it feels like an object-oriented language, even though it is not. And we covered a lot of things. Basically, we did a lot of needed implementations. And today we are going to be looking at still following the building on what we did last week. That's modules and struct, like how to use them, how to structure your modules, all of those things. So we are still going to be following that same direction, still building on what we did last week. So this week we are going to be talking mostly about encapsulation and two things basically: encapsulation and ownership. So those are the two basic things, or the two topics we'll cover this morning. And I believe by the time we are done with this, with the understanding of that we have from modules last week, from last week's class, we should be confident enough to talk about, oh yeah, I can build in Rust. Like, not as an expert, yes, but as somebody that can see Rust code that can, tackle any challenge, no matter how, just basic challenges, right, in Rust, and say, oh, I know what is happening here. I can read this, and most probably I can even try to solve it, right? So, because the idea is we've covered most of the basic things you most probably need to know as a Rust developer, and also we are now going to be going to the advanced ones after we complete this. But it's important to understand the ownership principle in Rust, because it's like the foundational rule you need to know in Rust. It's very important for you to understand what ownership is. But before then, we'll talk about encapsulation, and then we'll move to ownership. But before talking about this, let's take a brief to see what we did last week and just like go through it. And so what we did last week was we talked about modules, right? And from our understanding of what we talked about, we said modules is just a way of putting your code together, like providing structure, providing organization to your code. So rather than just writing your code in one file, you want to split it into modules, right? So that it is easy for it's you are simply modularizing your code, right? So that's where the name modules come from. So it's providing modularity for your code, providing organization for your code. You are structuring your code, you are grouping it in such a way that it is easy for anyone to see, no matter how many people are working on the project, to see, collaborate, and also add their own implementations from anywhere in any part of the world. And you guys can collaborate, knowing fully well that you are not interrupting yourself, even though you are using the same libraries, or you are picking from the same MPA library, or probably from the same roots library or whatever. It does not really matter, because you know that this code has structure. So whatever is happening at the root file, you know that it is coming from within a module that exists within that crate or that project, right? So we spoke about modules last week. We talked about how to create a module. We first started with the new method that we talked about 2 weeks ago, when we talked about struct and how to define structs, the functional declaration, like, and the method declaration, all of those things. We mentioned them, and then we also spoke about how to define your modules, the types of modules we have, the inline modules, or the one you defined like external modules rather, where you define them in like building also within the file system, and how you can write them out. So some of the examples we looked at, let me just open some of them. Do I still have them open here? Okay, terms of I don't even know which one is this. Okay, so let me check this. I think I have this open. Um, okay, yeah. So let's go back to these animals and backyard that we used. So for the backyard, let me open the backyard, because that was what we started with. Oh shit, I closed that guy. Okay, we'll reopen that. So for the backyard code that we did, let me expand this. Yeah. So is this big enough, please? Can you guys see it clearly? Okay. So um Okay. So we have this. So this is what we had last week, right? This was the example we started with. So we started with this example whereby we have this structure, we add this structure, and then we define something like a backyard, and we define what we wanted to have within it. Say for instance, we wanted to have something like this a backyard, right, whereby you have garden and you have the house and then you have things in the garden. So we wanted to create something like this, something just that you can relate to, real life scenario, but then you can relate to. So imagine if you're building an application or a backend service or whatever, or probably you are building a backend application, right? You're building a backend that service, or you're using Rust to create like structure of how your application will look like. You can probably say, okay, you want to build a gardening application of some sort, and the backend logic is contained within this Rust program. Now, this is probably the structure you go with, right? And that was what we explained last week, that you will have your source file like this. Remember, we said we have the source folder, we have the cargo.toml file, which defines all your dependencies, your packages, and other files that are related to the current project, right, which is going to be used for that project. Also, we mentioned that the cargo.log is used. The cargo.log is now what you use as so it is what is created for you automatically, right? It is what manages those dependencies that you already have in cargo.toml file. So you don't update it, you don't edit it, right? It's not, you are not supposed to, even though you can, but you are not supposed to update or edit it. So it's automatically generated by cargo for you, and you are not supposed to like do anything about it. And I explained, I show you guys another example whereby if I tend to install a dependency here, cargo.log automatically updates that dependency with all the sub dependencies and other information that is necessary for that, all the dependencies and all the metadata, the meta information that you need for that project. So we also spoke about the target, and that is where the build file is, right? All the build information and all of those things contained there. And the other information that is needed by the Rust compiler is within the target. So if you are defining, let's say you are defining a build, a dev release, right? You can see that here. Now you can see dependencies folder here. You can see the build folder here. You can see the examples folder, implementer folder. So, and then all of these things, but that's, we are not really, that's you get the build process, the build results. And then we talked about the source that contains our actual folder where we work with, the files we work with, the folder that contains all those files. And then we talked about main.rs, which is the entry point to our application, right? So everything you are importing, everything you are going to be using as modules, libraries, all of those things, you can import it from your main.rs. And we said you can either have two types. You can have main.rs, that is the binary crate, or you can have lib.rs, which is the library crate, which an example is this. And then we talked about these are modules, right? And we gave two examples of where you can create modules last week. You can decide to create something like out.rs like this, and then since this you are creating out.rs, which is supposed to be a module, then you link it to the folder that you are creating. But because we have created the mode.rs here within out.rs, that automatically says that this module is a this module here, this house here is a module rather. So you have already linked that by creating the mode.rs. But if there's no mode.rs here, you probably create your house.rs here and link the files that you want to be public within the house folder. So we spoke about all of these things last week. Showed you guys the two ways you can create it before we talked about the inline module definition. So let's say you want to create this also. So this is equivalent to having it in module folder. You can see it's the same thing basically, right? So you can choose whichever pattern works. So we decided to go with the one where you have the module created. But for most application, you will see the module created outside. You will see a mode.rs inside the house folder. But in some cases also, you will see the mode.rs in the house folder. So you automatically know that, yeah, this is a module. So the two ways you can probably see, just to give you that sense of variants that you can see, that you will see online or see almost literally everywhere. So that is how it works, and we explain all of these things with examples also. Then we talked about main.rs here, using this as an example, how you import from different modules. Then we talked about importing from the root crate. You probably use the crate word, right, because you want to import from the root create now, and then you want to link all the modules that you want to fetch the file from. So let's say you want to get asparagus from vegetable.rs here. So you can see that the link is from main.rs. You have from your source.rs now, looking at it this way, and you have something in your main.rs. You need to link garden.rs, and within garden.rs there's something called vegetable.rs, and within vegetable.rs there's something called asparagus.rs. Now if you look at the structure, let's look at the structure from the left. You can see that the structure here defines okay, you can see that the structure for vegetable.rs defines asparagus here, right? So going back to main.rs, you can see, let me minimize this a bit. You can see that we have the garden. Okay, these are just like definitions, so this doesn't give me like the structure I wanted to show you guys, but get the idea. The idea is that main.rs, then from garden, from the source folder to garden, then from garden to vegetable.rs, and then you have the asparagus. So that's the same thing we are linking from this place. I remember we said that the use keyword is more like an import keyword in other programming languages. So languages like any other language you can think of, like JavaScript, Python, literally any other language you can think of, like even Java, I guess, yeah, Java, all where you tend to import from other external file. But in case of Rust, we don't use the import keyword, we use the use keyword. So the use keyword is just an import statement, but in Rust we use the use, and it simply means import this file for me, import asparagus. But you need to define strictly, explicitly where asparagus is coming from, and these are modules. This is a module, right? And this, so you define the folder where it is located, you define the module name, then you define the asparagus, the struct or the enum or the function that is contained within it. But then before you can do this, you need to also mark it as public within the main.rs or outside. So it depends on how you want to go about it. So we spoke about this, and then we also looked at another example that showed us how to use the what they call it, how to use the inline module, right? So in this animal project that we created, we just scaffolded something just to make it, just to explain. So we just created this one. I wrote this one out just to like show you an example. And when that was ongoing, we now added this, we created the structure to look like an external module, and then we added some files just to show how this thing is, and then we now created some inline modules also just to buttress how inline modules work also. And then this, for instance, is a module. In the module you have functions, right? Functions that are mostly private by default. Remember, your modules are private by default, right? And whatever you have in your modules also are private by default. You need to explicitly say that they are available for you to be able to use them if they are outside, right? So that is it. So now, but within this place too, I need to also specify that this, because it's an inline module, I have access to it from here, then I can make use of it. But if it's coming from an external module, I need to mark it as public. So every external import, every external module that you want to use within the main.rs file or within any other file needs to be marked as public, else they will not be accessible. So that was where we spoke about visibility, and then we mentioned visibility. We gave we spoke about visibility a lot. We talked about different examples, and I shared with you guys examples from different places. I shared with you example from Rust Labs, where we have how to explicit declaration, privacy rule, all of those things. And then we also shared from, I think, the Rust book. Yeah, we shared from the Rust book. So I gave you guys different resources just to buttress the point of visibility with respect to modules, using the pub keyword, the private keyword, all of those things combined, just to make you guys understand it, right? And yes, that's basically what we did last week. We did a lot of those things last week. We covered a lot of them. We spoke about it, made it clear as much as possible. And now today we are going to be going into, now that we already understand the module system, the module implementation, module principle in Rust, and the rules, some of the rules that govern it, and how to make the imports, how to see how it works, how to visualize the file system, the structure, the module structure. And then we talked a bit about the visibility. In fact, we talked a lot about visibility, and we said it's private by default. We talked about the modifiers also, when to use the super, when not to use that, and all of those things. And then after mentioning all of those things, then we now want to go into encapsulation today. So, like I said, remember that I said I always say that we will come back to most of these things eventually when we write, like when we have an exercise to work with, we always come back to it. Now, one more thing I want to mention is there's this Rust by example book that I thought I've been giving you guys, but I realized I've not been using it at all. Like I've not even shown you guys. I don't know if I have, but I just want to like mention it again, even if I have not, or even if I have. So when you have this Rust by example, now Rust by example is is this book similar to the one we've been using, right? Similar to Rustling, similar to there are different resources, like I said last week, where you can use to get examples. But this provides you like um code that you can actually run also. For the person that was asking the question last week, I can't remember who the person was, but then and I answered the question that there are a lot of ways, but I don't know if I mentioned this Rust by example resource, but this is also it's also interesting to use. It works also. You can learn from everything we've defined, everything we spoke about, see examples of it here. And you can also use this too because it gives you like different examples you can see. It's similar to what we've seen already, right? But at least this is an extra resource, extra exercise you can try hands on if you want to see how dynamic the Rust exercises can be. So these are just examples I wanted to point out. And so we also be using this also with respect to everything we use. So we just pick from different places to show you the difference and different dynamics that we have in Rust, right? So yeah. And so we talked about modules. So we already completed that, at least for now. We'll come back to it eventually when we need to. But we've completed that for now. We've seen how to call them, how to make use of them within our main function as inline modules or modules. So okay, now to go into today's topic fully, we are going to be covering encapsulation. Encapsulation. Now, encapsulation is, let me not this one, let me use this. So encapsulation basically, just follow what we've been using before, is just like the name implies, you are encapsulating something. That means you are keeping it within another thing, right? You are keeping something within something. So it basically means you are hiding it, right? Yes, you are hiding it. That's the meaning. So when you say encapsulation, it simply means you are hiding a resource. That's the idea. So, but in this case now, since you already understand the module system, we've already treated struct. Now, let's talk about how you use encapsulation or why you use encapsulation in Rust. Now, the first thing to see or to understand is, like I said, encapsulation is when you hide something within something. So it's a practice of hiding the internal representation of an object. So it simply means you are hiding details about something. So if I say I'm encapsulating this, just like a capsule, right? A capsule is just, you see an external object or entity, and then you see something inside that thing. Now that thing that is inside is actually what you need. You get, but you're encapsulating it. So you have a capsule. A capsule, the outer wrapper around the capsule is not most probably what you need. What is inside of it is what you need. But the entire thing, both the internal one and the external one, is what we refer to as a capsule. So now you can look at this coming from the word capsule, encapsulation. So it's a capsule, right? But then it simply means you are covering something, you are hiding something in something to protect it from something. But yeah, you can make use of it anytime you want to make use of it. Now, encapsulation is commonly used or mostly commonly used to enforce some invariants on the object state. Now let's go back to the ticket struct that we have before, right? Now, remember also last week we installed Rust and then we scaffolded everything you need to run Rust locally. So in case you've not done that, there's a video for that from last week and for modules. You can always go back to it to understand that. But then let's move on. It's going to be as clear as possible, so it shouldn't be too out of place from what we already know. So now let's talk about understanding using this ticket struct that we already treated. Remember, we created this ticket struct whereby we say we wanted to create a ticket that's let's say a ticket system, something that a ticket that you can buy, right? Obviously needs to have a title, a description. Sorry, not ticket you can buy, rather a ticket, something like Jira, right? Whereby you can list your ticket for a task, and then when you list the ticket for a task, you can move that ticket as being in progress, completed, or ongoing, or you've not even started at all. So we created this ticket struct then when we wanted to create the program. Now we created something about the program, but it was just basic, right? We created that 2 weeks ago. And when we did that, this was the structure we used, the ticket structure. Now, in this ticket structure now, all the fields are made public, right? Meaning that there's no encapsulation. So, what do we mean by that? Let's proceed. You must assume that the fields can be modified at any time, which we understand now from modules, right? Because remember that for modules, when we created modules last week, we mentioned that, let's look at the backyard again. We mentioned that in this vegetable.rs now, you can make use of this. Why? Because you mark it as public. Now, let's go back to the animal project too. We say you can only make use of this also because it is marked as public. That's the functions too, right? But let's say we do not make use, we do not like make them public for any instance. Now, it means they won't be accessible within this main.rs file. We established that last week, right? It will not be accessible from anywhere else. Now, that means that if it is made public, then that means there's no encapsulation. That means it can be modified at any time. You can set to any value that's of the type, right? Because if it's a string, that means you can set any value of it. Now look at what they said there. You can't rule out that a ticket might have an empty title or a status that doesn't make sense. Obviously, anybody can write anything to it since it is open to be modified by anybody. Now, to now enforce stricter rules, because that is more like the essence of, that is one of the powers that ROS gives to you. You can enforce your rules and you can make sure that the program works exactly the way you want it to work. Now, to enforce stricter rules, you must keep the fields private, right? We can then provide public methods to interact with a ticket instance. Now, we'll see what this means. Let's proceed. Now, those public methods, we have the responsibility of upholding our invariant, e.g., a title must not be empty. Now, if at least one field is private, it is no longer possible to create a ticket instance directly using the struct instantiation method or syntax. Now, let's say we have something like this, right? Once we mark one field as private, you can no longer do this, right? Because that means you can't just create a value for it. That means you need to provide a method to be able to interact with the ticket. Or we'll see what we mean. Now, you've seen this in action in the previous exercise on visibility. Actually, we've seen it in action. Now, let's go back to it just to see it a bit. This side here. Is it this? This is the other example here. Okay, now remember we said it's private by default, right? Now, a private entity can only be accessed within the same module where it is defined or bound on submodule. So we've created extensively, we've done a lot of those things, right? And now we say we have some modifiers. We didn't talk about the modifiers yet. Yes, we actually didn't talk about it. I think we should have talked about that before going to encapsulation. So we can modify the default visibility of an entity. Let me just talk about this a bit. The visibility modifiers. Now, for visibility modifiers, what this means is that you can modify the visibility of an entity using a visibility modifier. Remember that for visibility modifier that we spoke about last week was just the pub modifier, that's the public, marking it as public alone. But let's say you want to make it accessible from let's say within the parent element and the parent module alone and not anywhere else. Or you want to make it accessible within just another file, just one file within the entire file structure or within the entire project and only within that file. But you know that once you mark it as public, any other person have access to it. But you don't want that. You want it just within one particular file or within the parent element alone or within the root crate alone. Do you get now? I don't want it to be used anywhere else, not even within an external library. Now, how do you do that? Now, the visibility modifiers gives you access, that power, that flexibility to do that. Now, there are 4 of them, basically, which are commonly used. You have the pub. You already know what the pub does, right? The pub actually shows you that you can use the file anywhere within and outside where it is defined. Remember we spoke about that. If you look at this thing that we defined already, remember that when we mark this as public, it simply means we are giving access to it from anywhere else within the project itself. Now, that is that. Now, when you define it as crate, right? When you mark it, let's say you have a what do we do now? So let's say we have like a name. Should we give a name? And let's say we have a name type. inside of the struct, right? Now, remember we already marked this as public, right? So now let's say we want to mark this as a name. If you mark this as pub like this, it simply means that anybody can make use of this name from even the main.rs. Do you get it now? But let's say I don't want it to be used within main.rs, but only within, let's say, okay, let's say I want it to be used within only main.rs now, for instance. Or no, let me restrict it a bit. Within, let's say, um dog.rs. It's not a perfect example. Or within cat.rs, right? That's just an example. Now, if I use it as pub, every other person can use it. It can be used within these wild animals. It can be used within the main.rs. It can be used anywhere else. But that's not what I want. Now, let's look at another way to do that. We can use this path in module. So simply, we can restrict the module where it is located. So we can use something like the crate, right? And we can use this pet, and we can use the cat actually to like define the place we want it to be. Just a file system. Now, this is what we need now. Now, in path to module, right? It makes the entity public within the specified module. So that means if you mark it like this, you're only making it available within a specified path. Do you get now? So say let's say we have something like this now. We have let's see why is it not working? Expected comma or what? Pets, dog. So basically now what we are saying is that let's say we want to make this available within another module entirely, right? We can do this and mark the path to the file system that we want to use. So now let's say looking at this now, this is the pub, right? This is the pub. Without this now, it simply means it's accessible to every other person, right? But then we want to make it only used by, you can see that there are two other options, but we'll come to this ones eventually. I just want to explain how to use that within the file system. We want to link to another file system, right? Now, there's a way you can write a path here that will only be used for that particular path. Now, this is just an example of how to like link to that path, right? But this is not exactly how it is done. But then it's also possible to limit it to just that particular module. Now, let's say we want to reference a module, let's say the wild also, right? I'm just showing you how you can do the wild actually. So let's say we want to reference to just the wild module, right? And then let's say we want to reference the, I don't know which other one is accessible. Let's just say that there's something in wild, right? And it's a module. We get it now. So you can make reference to just that module now. That is what this is trying to tell us. You can make reference to the path. So you make the entity public within the specified module. So that means only that module can make use of it. You get now. So that's another way to make use of this. So no, you can't use here actually. So we just link the path, right? But this is not how to specify it. I can't remember how to do that right now. But then when we want to make use of something like that, we'll find it out. So that's the first way. Another way you can use it is when you use the create keyword. Now the create keyword in this case now, it simply means that you want to use this, you want to make this accessible within this create alone. Only within this crate and not an external crate. So that means external crates do not have access to this, right? So that is the first. So we'll talk about this one, which is makes it accessible to all files within the mode, outside the module where it is defined, every other crate. Now, but for this, makes it accessible to only a specified module. This makes it accessible to only within the same crate, but not outside. So that means no external crates, no external library, no external. Let's say I have these two crates, right? I define these two crates. Let's say I have backyard and animals. There's no, and they are working together. They are like within my application. I have the application, they talk to themselves. But then I can make it in such a way that this name here can only be accessed directly within these animals crates and not within the backyard crates. I can do that also if I want to. So those are different ways you can restrict even the visibility type also. So you see that it just gives you that ability to like create a lot of, it gives you that power, that flexibility to define what you want, restrict what you want. So now let's look at the last one, which is the super now. Now we already understand that super works just for like referencing the parent. So super works basically when you have like children and parent relationship. So now when we use the super, it simply means we are referencing the parent of a particular module now. So that means it can only be used within the parent of this module, not outside of it. Just like we see here. So make them see within the parent module, not outside. So those are the four visibility types like modifiers we have. So we call them modifiers because you can use it to limit and restrict and also extend the powers of the modules that you've marked as public before. So I think that is clear enough. So you can see an example here, and the example here says that you have this pop struct configuration. Now, configuration is public by default. We already understand. We've already marked it as public. But then you can only access the version object because it's the only one marked as public. You do this active that we do not mark as public here cannot be accessed. Now, let's see. Configuration is public, yes. We've already established that it's public, right? But you can only access the version field from within the same crate. Now, remember we defined what here? Crate. So that means it's only accessible within the same crate. The active field, which is this, instead is private and can only be accessed within the same module or one of its sub-modules. You get now? So that is it. So, but when if you do this now, what does this mean? If you remove crate, for instance, let's say we remove crate, it means it's accessible to every module, every crate, whether within the crate it is defined and external crates that have access to it. They can import it and access that variable or that item within the struct. But now that you do not mark it as you mark it as public within the crate, it is only restricted to that crate. Right. So I don't know if that is clear enough to everybody. The module visibility type. Any questions regarding or around that before we proceed? Okay, so I assume there are no questions. Okay, so now let's proceed here. So now that we understand this visibility, module visibility type, now let's go back to the encapsulation we're talking about. Now, we already said that within encapsulation now, we know that when we define within our modules, right, if we don't mark this as public, they will not be usable outside of that module. It's only within the module and its sub-modules that we can use it. Now, okay, so now let's say, now how do we define it? How do we instantiate that module? They said we've seen this in action. We now need to provide one or more public constructors. That is static method. Remember we mentioned static method or function that can be used from outside the module to create new instance of a struct. So luckily we already have one, ticket new, as implemented just exercise. Now, in that method, we have, remember we defined something. Let me copy that. I think I still have it here. Rust playground. Yeah. Yes. So we still have the struct we created that day, where we created this struct and we implemented it. Yeah. So let me just move this to the main.rs. So see, I am to like this as public. Make this one work. Okay, so do this. So remember we have this the other day. If you remember that struct, the class for struct that we had, the struct class that we had, then we talked about this, and now that's basically what this is making reference to. And within that struct class also, we defined the method that the new method that we used. Yeah, remember we used the new method. Did we use it here? No, I'm not sure we wrote it. So we talked about the new method syntax call and the function call syntax. Okay, but basically what this is telling us that we already have a ticket new implemented. We did not implement that. No, we did not implement that. Let me just get it from here so we don't need to write it again. There's nothing here. Okay, let's just proceed. That what is needed to write eventually if we need it. But basically what we have is that from the implementation we have a default, right? And we have an is open. Excuse me. And then we have those two basically. And then we talked about how to access the files within it. Let's say we have the method call, which is this, or after you created an instance of your ticket, or if you have the function call syntax, which is this, how to watch references directly. So let's proceed with this. So he said, how do you access this now? So accessor method now. So what this is basically talking about is when you talk about assessing a struct, we already understand assessing a field or a struct or in a normal function within a module is private by default. And in this case also, in the case of this ticket now, all the variables, all the fields within that struct are private by default. Now we provide a public constructor that enforces our validation rules of creation. Now that's a good start, but it's not enough. Apart from creating a ticket, we also need to interact with it. But how can we access the fields if they are private? We need to provide assessor methods. Now let's look at what they are now. Now assessor methods are public methods that allow you to read the value of a private field or fields in a struct, right? So assessor methods are methods that allow you to read the values of a private field or fields in a struct. So that's basically what they are. That's basically what we refer to as assessor method. Now, look at this now. Rust does not have a built-in way to generate assessor methods for you. Like some other languages do, you have to write them yourself. Because why? They are just regular methods. Right, so they are just regular methods. So, but then let's like I said here, we'll come back to exploring encapsulation in more details. So basically what we are talking about is that in this case now you can see that this is private by default. It still boils down to the same concept of modules and visibility, right? So but then when we want to talk about it, like I said, we always come back to those things we talk about, but we don't want to dive into everything now. The more we need them, the more we explore them, like we unwrap them little by little, just like we are peeling an onion. We will unwrapping their layers until when we have need of their core functionalities or implementations. But for now, let's keep it as simple as possible. Just know that within a struct, right, within a module, you do not have public accessibility, right? But you can use an assessor method to access a private field within a struct, even if they are private. So that's basically what an assessor method is. You can use their public methods that allow you to read the value of a private field or fields of a struct. So that's just it. Now let's go to one of the main and most important thing that I want to cover today. We have 1 hour to do that, and hopefully we can cover that in 1 hour. Now it's called encapsulation. Now before we go into encapsulation, let me see if there is anything on encapsulation I can show you guys before going into ownership today. Rather, okay, I'm not sure there's encapsulation here, but let me pick from another one and check. Probably want to use the Rust hook here. Okay, so let me pick encapsulation. Probably there's something I need to mention that's not there. Yeah. So let's pick this. Now, encapsulation that hides objects. Okay, yeah. Object properties of object-oriented language. This is way into the book. Yeah, okay, let's just talk about it. Now, remember I said at the beginning of the class that these are things that make Rust feel more like an object-oriented language. Remember I mentioned that, right? And now, this is basically what I mean. Encapsulation is one of the properties of an object-oriented language. So for object-oriented languages, we have 4 properties majorly that we'll talk about. Encapsulation is one of them. Polymorphism is one of them, right? Abstraction is one of them. So when we talk about these properties, encapsulation being one of those properties means that you are hiding implementation details. Remember the example of the capsule that I showed you, that I explained the other time, whereby you have, let's say you buy a drug now and we call them capsules, right? So you have a capsule. A capsule simply means you have a package, a wrapper, and then you have something inside. So whatever is inside is the most important thing. The wrapper around it is just a layer to provide, protect, or just to keep it enclosed. So that's encapsulation. So as the name implies, also in real life, it's simply the same thing in literal sense in computer programming languages. So whether it's Rust, whether it's Python, JavaScript, Java, C#, C++, whatever language you are working with, it basically works the same way. So encapsulation gives Rust that ability to feel like an object-oriented programming language. It's because it provides you the ability to hide implementation details. Now, and it simply means that you cannot access something until you have access to that thing, until you are granted or you are given access to it. Now, do you get now? And you know that Rust already provides you a way to make some things public, but by default, some things are private. So now the encapsulation there means that private ability, right, that those elements, those entities have now is the encapsulation we are talking about. They're encapsulated within something, but then you can bring them out using another thing entirely. That's just the idea, right? I don't want to go deep into these things yet, but we'll talk about it as we move on. Yeah, like I said, we'll be peeling them little by little. So encapsulation is required for considered object oriented. Then Rust meets that requirement. Do you get now? So you could argue that Rust is an object oriented language. Inheritance is also part of an object oriented language property. Like I said, there are four: inheritance, encapsulation, polymorphism, abstraction. Those four things are required. So Rust has encapsulation, right? It has inheritance. So you could very much argue that it's an object oriented language, even if most people say that it's not. So, but then it maintains some of the properties of an object oriented language, and then Rust follows that property. And then because of that, you could say it's part of it too. So for this polymorphism that I was talking about, but yeah, don't let us dwell into this. Let's go into what we want to talk about today much, which is the ownership, right? So yes, let's talk about ownership. But before then, I still feel there's something I want to show you guys from here. I've not seen. I wish I could see that here. Encapsulation. No result. Wow. Okay. Okay. So let's just, like I said, we'll come back to it in other chapter. There are things about encapsulation in other places that we'll still make reference to them. So now let's continue. Let's go to ownership for a bit. Right. Let's talk about ownership. So what do we mean by ownership? Ownership is a very important property in Rust. It's like I said, like I've been saying from the beginning of this course, it is like the foundational thing that makes Rust different from every other language. Or most other languages, not every, most other languages have, because some languages also have this ownership rule, they have this ownership property also within them, but the way Rust uses it that just makes it stand out. And because of the whole Rust strictness and no playful, no allowing jargon, that trait already gives you that flow. So but now let's look at the ownership property in Rust. Now how does it work basically? Ownership, just like the name implies, and I always say something that in Rust, every time you hear of is literal. Like if you hear something else, myself simply means myself, like it's a literal term. So ownership in Rust also means that you are talking about the ownership of something. That means you own something. So whenever you see ownership principle in Rust, it simply means ownership of a particular thing, let's say a variable, a value, or something. Now how does it affect Rust, or how is it used in Rust, and what does it mean? So I'm going to be using different resources. I'll use resources from here to explain, I'll use this to explain, I'll use the book to explain. The reason for this is because ownership can be confusing, right? It is very important once you understand the ownership in Rust, right? You've understood one of the core functionalities of Rust, or one of the core feature of Rust, right? So because remember when we explained that Rust does not have a garbage collector and all of those things. Remember that explanation from 2 weeks ago, but then let's just talk about it again. Now, if you solve the previous exercise, let's continue from here. Using what we've talked about, your assessor method will probably look like this. Right? What is the assessor method? This ticket, remember from this ticket that I copied here, you don't want to create a file like this just anymore. Right, we can't like create directly, but we can use an assessor method. Remember, an assessor method is a public method that allows you to access or reference a private member of a field of a struct, or a private field of a struct, right? So in this case now, the ownership here simply means that, okay, not ownership now. Let's look at the assessor method first. The assessor method in this case are this kind of methods. In this case now, you want to reference title. Right, remember that we said in this case now, if you are looking at this from a module perspective, this is private, this is private, this is private, but I can write implementations. Remember when we talked about implementations, which is why I copied this. I can have implementations for this struct, and implementation for this struct, right, can define getting me a title. Like for instance, I can say something like this now. Let's say I want to get a title, right? And the title in this case is this particular title here. You get now. Now it's similar to what I did here. Now this one I helper function, but then let's say I want to write something like this. So I can say title. So I want to have access this title, something like this. Now you can see that that's the same thing we have here. But in this case now, because I want to make it accessible, I need to mark it as public. Now this is an assessor method. simply that I want to access a field within my struct. Now, how do I access it? I need an accessor method. What is the accessor method? This guy. I don't know if that makes sense to you guys. Right? Does that make sense? Are we together, please? Hello. Okay. So now that's an example of an accessor method. Also, we can create accessor methods for all the fields. Remember, we said that we can't get them directly, right? If they are private, or then we can create accessor method to reference them, and then that means we have access to them again, right? So we can say accessor methods for what status. Oh, am I right? All right, so we can do that accessor dot status also, right? And then we can provide. So now this way, now we can use this accessor methods here, all of this, to access the fields inside our struct, basically. So that's just what we refer to as accessor methods. That's just it. So from that now, we can see that you already understand this accessor methods, right? That's saying that your method probably look like this. Now, these methods compile and are enough to get tests to pass, but in a real world scenario, they won't get you very far. Now, consider this snippet of code. Now, we can read this, even though we've not done this, we can read this. It simply means that if ticket does status, remember that in Rust, we don't wrap the conditions around a parenthesis. Remember, I said that for if statement, for loops, for while loop, you do not wrap it around parenthesis. So in this case now, if what we are simply referring to is that if ticket does status. Now in this case now, what is dot status here? Status is referring to this status that we have here, this one. So we are simply saying that if ticket does status equal to do, right? Now let's look at this code and try to read it. We are printing what we already talked about print line macro now, even though I've not explained what the macro is in detail, but I've already mentioned that we are going to talk about it, and I already talk about like how you can use my print line to work. Maybe from the first 2-3 classes, we already have see them here. We have examples of print line. So, but then you can see this is going to print to you. Your next task is what's the title? It's going to tell you the title that we already give from the accessor method also. Do you get now? So now if you try to compile it, you get an error. Right? It says what? Use of moved value ticket. Now let's try something. It says let me see if I can use this explanation. Okay, let me copy an example from here. Let's create something like this. Let's copy this and paste here. We already have our implementation of that struct, right? Now let's create like this one and copy it here. Let me paste this here. So let's say we create a new ticket using this, and then this is to do. Let's just assume that's what it is, the status. Now we can use an enum for representing the status, but let's not go there yet. So we want to have if no parentheses, right? New ticket dot. We want to use title now. In our case, we use get title as our accessor method, right? Excuse me, as our accessor method. So we can use get title here equal to do, right? And here we can say that what print line your new task is, then reference what new ticket dot get title, and this one will be get status rather. Now I'm trying to show you guys an example of something here. Now you can see the first thing we see here is what, even before I compile it, you can see there's an error here. And what's the error? You say use of value new ticket. Now value used here after move. Now you can see this now. It says new ticket move due to this method call. Move occurs because new method has type ticket, which does not implement the copy trait. Now you can already see the reason why this is complaining. Now the ticket get status takes ownership of, I want you to mark this word ownership now, takes ownership of the receiver self, which moves new ticket. So please guys, if you've not been following this class from beginning, please, I want you to follow this part because this is where we talk about some things, references, move copy, references, moving files, I'm sorry, moving value, reference to value, moving values, copying, and ownership. Because all of those things you need to know about them when you talk about ownership. So please, if you don't understand up to this point, please talk now so that we can revisit it because this is very important. Now that we're talking about ownership, we need to make mention of some things, right? So please, like I said, if you don't understand up to this point, please talk about it now so we can go back.
Yes, so I don't know about references.
Sorry, you said what?
Yeah, I don't know.
Don't know what? I didn't get your question.
The references you just mentioned.
No, we've not talked about it. I'm telling you that we are going into those things now. We need to talk about them. So if it's not clear to you yet, please just like talk now so that we can talk more about it. Do you get?
Yeah, please. I don't know. I'm not completely clear with it.
Yeah, we've not talked about references yet too. Like we are coming to references. We are going to talk about it. I've not gotten there yet. I'm just saying that everything we've talked about today so far, do you get it? Do you understand it so far?
A bit. I came in a bit late, so I did not get the
Oh,
gist from the beginning.
oh, okay. No problem. So once if I get to a part that I've talked about today and it's not clear to you when I continue the class, please just tell me about it. Just like talk about it or draw me back a bit so that I can mention it because I don't know where you missed and I don't want to start from beginning. Do you get? So I'll continue, but if there's something I mentioned that you didn't pick, then just bring me back to the class or to the beginning of the class. Does that make sense?
Yeah, thank you.
Okay. All right. So Musa, do you have a
Well,
question? You have this
yeah,
thing.
but
Okay, please go ahead.
so my question is that like the the like using implementation, like what do we really need to use in like implementation blocks? Why can't I just implement it in my main file? I
So
don't
what
know
do you
if
mean
you
by your
understand.
no, what do
Like
you mean
that
by your
I like that implementation method.
this one?
Yes, I'm a bit confused. Why do I need to do this? Why not just do everything inside my function main stuff?
Okay, so this is it, right? The reason why this is done like this is to is this is how Rust syntax works, right? So when you have the struct, remember that struct is just a type. Rust is this struct. Whenever you define a struct, you are defining a new type. A type like string, right? Like this string type that we have been using since that we used here is a type. The U8 is a type. The bool is a type. Do you know? So now this ticket also is automatically a type. Do you get now? But now every type you have default methods that you can perform on them. For instance, you can perform a method of let me explain this now. Let's say you have a string. You know you can define the length on a string, right? Now this is not like I'm just giving an example. This is not written, right? But you can define the length on the string. You can define like a copy. You can use a copy. You can have a copy on the string. Now for an integer, for instance, you let's say for instance you wait. You can have also other methods like you can wrap into, you can saturating methods, all of those things that were treated in previous classes. Now those are methods that you can do you get now? You can have all of those things. So you can have these are methods that you have on this data type. I don't know if you get my point. Now those methods you have are what allows you to be able to do things like okay, let me give you an instance. So let's say you have something like title. Let me mark something here. Um what is the easiest way to do this? Okay, let's say we have new ticket dot. Let me say title here dot. Now these are methods. You see all these things you see here? These are methods on the string. Do you see it? You can split it, you can pass it, you can convert it to a byte, you can convert it to a mutable byte, you can convert it to a mutable pointer, a mutable string, a mutable vector. You can make it as a pointer, as a string, as a byte. You can define you can get the capacity of the string. This will give you the character indices. This will give you the characters, more like as a list of characters, an array of characters. You can clear the value of that string. You can see if it contains a value in the sense that it contains another string. You can drain it. You can encode it to UTF-16 instead of UTF-8. You can check if it ends with a particular value. You can see if it's equal to, by ignoring the SI case, if it's equal to another string. You can escape debug, you can escape default, escape Unicode. You can find the value within it. You can get the value within it. You can get a mutable. You can get a value by allowing it to be mutable. You can get unchecked. You can get unchecked mutable. You can insert a new value to it. You can insert a string to it. Now, you see all of these methods I'm mentioning here. They are methods that are allowed for you to be able to perform on this string. Remember that title is a string from here. Do you get? So now, the reason why you have all of these things here. Now, if I do the same for, now let me define a new struct inside here just to show you something. Now try to follow what I want to do here. Now you see that this title now that I defined here has all of these properties here. As much, see how plenty they are, like from the beginning to this the end. You can see anyone that is marked as purple, right, is a method that you can access on that thing up to this point. You can see there are a lot of methods. Now let me define a string. And if I do a string now, you can see that the properties I have are smaller. See, that's all. Now you see that there's a difference between the methods that exist on a boolean and a method that exists on a what? On a string. I don't know if that makes sense to you. Do you get it? There are different methods. There's a method that exists on a boolean. There's a method that exists on a string. Now, those methods that we are talking about that you can see from here, you can see that on the boolean you have then some, clamp. You don't have all of those in bytes, as bytes, get, contains, all of those things anymore because that's for string. A boolean does not have that. But you see, like boolean has its own thing, like get greater than, less than, equal, less than or equal to, less than, not equal to, partial compare, bit, and do you get now? Not all of those things. So the methods here now, where am I going to? What I'm trying to point out is that all of these now have their individual methods. Now you can, because they are types. Remember I said that they are type. A string is a type, right? U8 is a type. Boolean is a type. A ticket that you define with a struct is also a type. Now, because it is a type, you have the liberty now. Rust gives you the ability to create methods on it that can do something. So that means within this ticket now, you can create a ticket, right, that can do all of these things. You can create a ticket such that when you define new tickets now, do you get now? Now, let me see the methods on new ticket. You can see the method on new ticket. I have get description, get status. I know I said that anyone that is purple now is the method you have on it. Remember I said that. Now you have get description, get status, get title is open. Now let's see where these four things are coming from. These four things are coming from the implementation that you have here. See it here. It's open, get title, get description, get status. Do you see it? So now why we use the implementation is to be able to implement methods for that data type. Now remember that it is very important for you to know that this is now a data type. It's a custom data type. It's the same thing as integer data type, string data type, boolean data type. But this case now, it is your own data type. You created it. So because you've created it, you want to define what it can do. Do you get the gist now? Yeah, Musa, I don't know if you understand what I'm explaining. Okay, so now that's exactly why you need implementation method. So now this implementation is not just for fancy, right? But you need it because it gives you that power. Now look at the ability you have. Look at the flexibility that it just gives to you using the implementation keyword. You can have 200 methods. You see all the methods you have on the screen here, like the title dot, all of these methods. They define it inside the implementation methods so that you can do different things on them. Do you get? So instead of you having to reuse, so let's say you are creating a library or you are working on a project and then you know that there's you have a struct, let's say a person struct, and you want, anytime that person struct, you want to get different things, like you want to get, if the person has been upgraded to level 2, you want to get the cards, the number of abilities the person have. You know, you can have different methods on it. So let me just give you an instance to explain. So let's say I have something like this: struct person, right? So person is now a data type automatically. Do you get? And within the person, I have the name. I have the name, data type of string, right? What am I doing here? I have the name, data type of string. I have age of U8, right? Because you understand the person can't be more than 255 as age in being your game. Let's say this is a game. I'm just trying to point out something to you. Then you have nationality. Let's just assume that you're playing a real life game, a real world real life game. And nationality is an enum, but it is as a string for now. And then you have other properties like colony. Colony in this case is whether it belongs to a colony or not, or you can leave it as a as colony or belong to colony like this and say boolean. Now I'm just defining a game, for instance. This is how like you build games with just data structures, and then you have something like level. And level in this case is like U8 because you want to go from level 1 to maybe level 10 or level 100. Yeah, like upgrading your levels, you're upgrading things. You now have things like asset also. Like within asset, an asset is also going to be a struct. Do you get now? So asset is going to be a struct now. Now, do you get? My asset is going to have a name also. Now, my name, the asset is going to have a name or an ID. It's going to have an ID of some sort. Or I can leave it as U32 because I expect it to be as large as possible. Then it's going to have attributes that's coming from an enum of some sort. I'll leave it as a string for now, but it's going to be an enum so that you can power up and all of those things. Now, the assets, I can have multiple assets. I can have an array of assets. I'm just giving an example, right? But just you understand that. So I can have assets. Now, the assets I have now, also I have what else can a person have in a game? You can have weapons. Okay, weapons assets are like the same thing. So you can have an array of assets, right? And then also within the assets now, or within the person structure, you can see if he has what else? Let's say he has like a sidekick or all of those things that you have in games. Like let's say you have a dog or a cat or power ups. Power ups are different from assets. Power ups. Power ups also can be an enum, right? Can be power ups. And just you understand now, you have to define the power up as enum too. And then within the power ups also, I can have what else? So now let's say power ups are different also, and then I want to have defense level, attack level, and let's say attack level is U8 because it's 100. So let's say attack level is from like 1 to 100, all of those things. Now, do you get the way I'm creating this? Now, you see, I'm just creating this person now. Now, imagine the kind of implementations I can have on person. So if I want to implement person now, I can decide to say get name, function get name, right? Now, this function get name is going to return what? Self.name. So that means I have to put self here. And I have to return a string type because name is a string type. So the same thing I want to do for calculate. Let's say I want to calculate let's say I want to calculate win percentage, right, per time within the game. Now calculating percentage is going to require me to get the assets I have, the current assets, my attack level, and all of those things. Now calculating percentage, let's say it returns equate for me, right? And in this case now I use self. Now I get your assets, or let me say I get your attack level first. Let's say I multiply your attack level by what again? Your, I don't know, let me just give an instance of assets dot something dot whatever attributes or something, right? And say divide by 100 since it's percentage I want to create. Now, do you get, you know that everything, all of this needs to have their own logic. I'm returning the value. Then I can say calculate lose percentage also, right? And then I have self, and then I return a U8 also. Now I return something. Let's say I now return player level. Like let's assume I have another function that says how long to upgrade, right? And I have another player that gives you player category, You get, maybe category is what I use to calculate the number of wins, number of losses. I can now say self dot calculate, or I can have, yeah, let's say number of wins, number of losses, number of wins, and I have and down for number of losses. And then from here I want to say let's say, but now you see how this thing is getting longer. One, I already have a method 1 2 3 4 5 6 7 8. Now all these are functions I can define outside somewhere. But then if I define it inside person here, it means that whenever I implement a person, just one, I have access to all of these methods. So now let's try it out and see. Let me define a person. Let's say I just create a person, like simply create a person. Oh, this is going to be long. Jeez. So let me just create this, like I don't want to write it again. Yeah, okay. Let me just see if I can use this to create like a person. Better still. Okay, let me just copy this, create a person here, and say let's let me copy some of the attributes I have here, so I need to use it also. Try to work out. Okay, so let's new person. Right, so I want to create an instance of the person. So by creating an instance of the person automatically here, what I'm doing is I'm going to change it to a string. Let's say I put my name dot into get. I put 12 here. I put nationality. I put my name again, Nigeria dot into. I put colony true. This colony out. I know there's no way to know the number of the colony I belong to, but there's a way I can do that within the game. The level, let's say level 3 assets. Let me just put something there. It's not going to work at this point, but then you get the gist because I'm not really defining anything. And so now, if I want to test it out, I can say new person dot. Now you can see all the things I have on this new person, right? You can see I have calculate lose percentage, calculate win percentage, get level. You see it now. I have all of these things I can define. Now, what else again? Simply because I have them from here. Calculate lose percentage, calculate. So I've not defined this one, which I can say player level is U8 also. How long to update? Let's say U8. Player category, let's say the string. Number of wins, let's say U8. Oh no, U32 because you can have thousands of it. Let's say U32 also. Now you can see this one, let's say U16 because how long to update? Yeah. This one too can be U16 because to be a bit longer. Now by the time I do this now and come back here, now you can see that I have all of these things here also. Age, asset, this, calculate percentage, calculate win, get name, all of the things I have here. And because I have things defined in them, you get now. Now all of those things physically means that what I already have data, like I have methods inside of them that does something for me. Now, do you get now? So this is why we have implementation. So now, if I'm creating a game, right, all I need to do is define what particular thing. Let's say I want to get the colony. I want to get dynamic. Like, do you get? Like, there are a lot of things that you can create, a lot of methods that you can create just to make it easy for you to work with. So you don't need to recalculate logic all the time. You already have everything to calculate your logic here, and even inside assets. So you can pick something from asset. You can implement assets too and start implementing it again. You can implement. Do you get the point now? So that's why we need them. So the help you to, like I said when I was explaining struct and implementation, I said implementation is basically what you use to define the methods of that struct. Just understand it that way. That's simply. Do you get now? Are we good? Right, everybody, is this clear enough to everybody? Okay, all right. So I believe that makes sense. All right, so since that is clear enough, let's go to the next thing. All right, so now we've already shown this, and you guys have seen the error. The error, okay, let's go back to the error that I was actually particular about to show you, which is this error. This error about, where's it again? This error about new ticket, which we get here. Where's this? Missing field. So going back to this, we see the error is going to come here. Now the error here is going to give us, oh, there's another error from person. We'll leave that for now. I'm not really going to bother about that. Okay. Um, yeah, power ups does not exist. I know. 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 System. Okay, so like this was just example. So I'm just going to comment this out because just to show you guys an example. It's not a working prototype yet of any game or anything. Okay, so now I haven't defined that. Now let's go to the actual thing. Yes. Okay. So now we've mentioned all of this. Now let's look at the example again. The error that we got. Now the first thing to notice is it said use of moved value. So it simply means that you cannot use a value, right, that has been used by another variable somewhere. You cannot use it twice within the same file. Now that's how crazy ownership can be. Like it can be a bit difficult, but like I said, if someone explains well to you, if you get it once, you've gotten it like for life. There's no point stressing again. It's just going to be that simple to work with. So now let's take a bit of okay. Now let's look at this way. Let's go back to the examples we have here. Now it says you can see the same error that we got is the same error that they see here. Now this is your first borrow checker error, right? Now let's look at the rules because it's more like rules, right? What we need to understand is that these are rules, rules that you follow to see certain things. So yeah, that's the first thing we want to talk about. So now, let's look at the rules of Rust. The first thing is Rust ownership system is designed to ensure that data is never mutated while it is being read. Data is never read while it is being mutated. Data is never accessed after it has been destroyed. Now, as simple as these three things are, if you've written complex code, and I mean like if you've written code on an enterprise level, and what I mean by enterprise level is if you've written code that that have to do with a lot of moving parts in terms of, let's say you're working on the banking or the financial system, financial software, whereby you need to talk about the things like the financial reports, the dealing with things like accounting records or fiscal policies or currency manipulation or talking about account creation, managing people, managing users, managing this and that. Now, all of those things can feel very simple and very basic, but the truth is those things can get crazy quickly. It can get, because now imagine, let's say using the financial system. Now let's say you want to deal with, there's a way banking systems work whereby you have things like the accounting side of it, right, working to ensure one thing, that's that. Then that's like the accounting side. Then you have the fiscal policy side that manages and calculates on the fly things about your account details, your records, data about your and about the entire bank accounts and things like that. Now I'm just giving an instance here, but then there's also a part that manages all the accounts. Now you know that when you're managing accounts, I'm calculating things about the account. They are two different things, but then they work together. So when you talk about currency, currency is part of account. So let's say you in an account you have three currencies with a bank. They have to calculate for each of your currency with respect to your account, with respect to the fiscal policy, whatever calculation they do. And then you also, that's for one, just two alone. Imagine calculating for 1,000,000 persons. And then when you're beginning to move data across, different from your profile, different from your complaints, your requests, your updates, your this and that, different moving parts. Now, in that case, now data is never mutated. Yes, you want to ensure that when you have updated something that is as sensitive as banking when it comes to financial systems. Now, you do not want to make mistakes. Now, the reason I'm using financial systems is because one mistake can cost you millions and billions if you're not careful. So in that case now, you want to ensure that you are not reading data that has been read. It's a very simple case. Let me give an instance whereby, let's say within the account, let's say within the account system, right? Let's say the currency calculation. So let's say we have three currencies. Let's say we have like 10 currencies in the system minimum. There can be a lot of like 60, 100 banking systems after. And within each of those currencies or banking solutions, now let's say the first one I have one that says let's say I have let's say within my account I have Nigerian naira, I have pounds, I have dollars. Now please try to follow this analogy to make it easier to understand. And those are the three currencies I have. But within the banking software currency, they have like 60 different currencies. Now it simply means that the amount I have in my naira bank currency now, right, if I want to calculate that currency, let's say the naira, I know that it fluctuates because the naira now will not be the naira value with respect to dollar in the next 5 minutes, in the next 1 hour. So that means it changes. That's different. Now let's say I have so amount in my naira balance, right? And then I want to use that same calculation. Do you get now to calculate, let's say, my report, or maybe when I withdraw money, you know that my account should automatically reduce. Do you get now? But what if I made a mistake when the developer, when I was writing the code as developer, let's assume, or some other developers made a mistake, and then you already defined a variable to store that particular result after you have withdrawn. Do you get now? But then after below the code, because of the way you wrote the code, maybe within an if statement, then outside that scope of the if statement is making use of the original value, not the value he has deducted from. So let's say I withdrew, let's say like 5 million naira, for instance, and I have 10 before. Now my current balance should be 5 million, right? But let's say the person now define it within a new statement that my balance is now 5 million, right? True. And it's assigning it to another variable, to the same variable that is updating it at the first part. But then outside that scope of the if statement that should give me that 5 million as my current balance, outside of it, my balance is going to be 10. Because if the code never gets to the if statement, I still have 10 million naira. Now let's say something went wrong there, and then outside the scope, I'm trying to perform another operation. After withdrawing 5 million, and then I go to my bank statement after withdrawing 5 million, and I refresh and I still see 10 million naira. I can withdraw again, and I can still see 10 million naira. Why? Because the value is not being updated. That's it. In fact, it's a simple bug that can happen. As simple as this thing I'm saying is, you look at it that why would that ever happen? There are many reasons why it can happen, because there are different and many conditions that work with banking systems. If you've worked on any one, you know that it can be crazy. The conditions can be like 20 to make sure that something happens. You are checking before withdrawal is done. So all of those things can happen. So if you are looking at those things now, as simple as that thing may be, because the code is a lot and the requirement is a lot, you can make that mistake. And if you make that mistake, you are costing the bank, because the person can keep withdrawing and the balance will never reduce. So now, in this case, this is one of the reasons why Rust, which I tell you that while the data is being mutated, why it is never mutated, you can never mutate a data while it is being read. That's what Rust ownership helps you to achieve. So it means that with Rust now, the original variable that holds the account, the original account balance, right, cannot is the owner of that account balance. It cannot be used anywhere else or accessed anywhere else. So that means what you can do is, whenever you update my balance, you need to destroy that particular variable, then fetch it again. That way you can never make that error anymore. Now those are ways to create like good code. So Rust then forces you to make that kind of thing. So if you are using Rust to be like a backend system, you are very sure that you can never, in fact, not that you can never, you can do that, but then Rust will point it out no matter what you want to do. So to a very reasonable extent, Rust will help you to check that kind of error. Even from the test cases, you will see that it will never pass, because you will know that something will fail. In fact, from writing the code, you will see the error. You will see a warning, you will see an error. So even if it's not an error, you can bypass the error, you will not bypass the warning. Do you get? So these are rules that govern it. So as simple as these rules may be, you may look at it that why it's never happen. It can happen, even in cases whereby it's not even up to like you working with banking solutions. These things can happen. So now in Rust ownership system, it is designed to ensure that data is never mutated while it is being read. That's one. Data is never read while it is being mutated. That's two. Data is never accessed after it has been destroyed. Now, these constraints are enforced by the borrow checker, a subsystem of the Rust compiler, often the subject of jokes and memes in the Rust community. Now, ownership is a key concept in Rust, and it is what makes the language unique. Remember what I said the other time? If you understand this, it's one of the unique part of Rust. So you understanding it already gives you a very good edge. Now, ownership enables Rust to provide memory safety without compromising performance. Now, all these things are true at the same time for Rust. Now, what are the things that are true? There's no runtime garbage collector. Remember I mentioned garbage collector in the first class, was it first or second class? And I explained how it works. I explained what we mean by garbage collector. Now, to give a bit of recap, it simply means that there are some things that you do not use in your code. Like I explained that when you have a code now, you can have a variable that you did not use. You can define a variable that you assign value to, but you never read it. Now, those are garbages at the end of the day, because when the compiler is compiling the code, it optimizes your code for you. It will read it from top to bottom. right? If there are functions, it will read the functions. If there are loops, it will read everything. Now, once it is done, the things you do not use within your code is going to try to optimize it for you. Do you get now? So most languages have things we call garbage collectors. So they collect the garbage and then discard it. Other, yeah, so almost most like languages do. Every language in fact that you can think about, that you can talk about, have something called a garbage collector. But in Rust, there's no garbage collector. Now, that's number one. So those are like things. So that means in Rust you cannot have things like unused variables. It's not possible to never even allow. You cannot have things like reassigning variable to a variable or not cleaning up after a variable. So let's say you're working with pointers now, for instance, and then you assign the pointer but you never delete the pointer. It never happen in Rust because they never allow you to do it. So it's not going to happen. So in C++, that's one of the problems why in C++ people tend to like run away sometimes, because there's always memory overflow because of simple things like this, because there's no way to know. And when you write C++, you have the flexibility of writing anything, like anything literally. So because of that, you can misbehave with your code. You can literally spoil the code yourself. The Rust will make sure that you cannot do something like that. So because of that, in Rust, you can't have issues with pointers, you can't have issues with, you don't even have a garbage collector. There's no runtime garbage collectors. And garbage collectors tend to get your program slower because they tend to read through, clean things for you that you should have done yourself. So Rust will enforce that you do it yourself so that when it is running, it is fast. It doesn't need to do any other check. It has done the check at code time. Let me use that word, not at runtime. So now those are the things that are true. So the first thing that are true is that there's no runtime garbage collector. That's the first thing. The second thing is, as a developer, you really have to manage memory directly. Then number three, you can't cause dangling pointers. Yeah, this is what I was explaining the other time. You can't cause dangling pointer. Dangling pointers in the sense that you assign a value to a pointer. Maybe when you are done with the pointer, you already give value back to the pointer or something, but then you do not free the pointer, you do not delete it. Or let's say you pass value from by reference, right, from one part to another part in your code, and then you just ignore that part, and then it's not being used anymore. It's just going to be dangling. It doesn't do anything. It doesn't go anywhere, right? And then you can also have double freeze. That's another example that tends to happen in C++ and other low-level languages and other memory-related bugs. Now, these are memory-related bugs, pointers, double freeze, all of those things. They are serious issues. Those are issues that most times, if you notice, when you have your program crash, most times, let's say you are playing a game. For most of you that have noticed this before, let's say you are playing a game and all of a sudden the plane just crash. The game that you are playing just says, just crash, right? And you just see an error occurred unexpectedly. You are trying to resolve this. Do you get? Those are issues that have to do with this. Is one of these issues. Is either this pointer issue, double freeze, or anything that has to do with memory, basically. So those are things that can happen. Also, this is something that happened not too long ago. This Microsoft issue that happened recently. This is what one of the reasons that caused it, just because of an allocation, a memory allocation issue. That's just it. So as simple as this thing may be, it can cause billions if it's used in an enterprise solution. Errors. So these are things that Rust is trying to prevent and provide solutions to. So now let's look at how Rust compares to other languages. Now languages like Python, JavaScript, and Java give you 2 and 3. That means they help you manage your memory directly, right? So so they help you manage that. Then they don't give you 1. Do you get now? So that means in Java and in Java, when you have things called garbage collectors, because definitely you have those things. So if you're familiar with Java, you know that there's something called garbage collector in the VM that's optimizes your code. But it's because of the way the VM is operating and all of those things. So Java also maintains this kind of thing that Rust has, right? So the idea is all of these things are very important too. Yes, but Rust gives you an edge over those other languages, and these are some of the edge. Now, languages like Python, JavaScript, and Java give you 2 and 3. That's, as a developer, you really have to manage memory directly. You can't cause dangling pointers, double freeze, but not 1. Now, languages like C or C++ give you 1. That means there's no runtime garbage collector, but they don't give you 2 and 3. So depending on your background, 3 might sound a bit akin. What is a dangling pointer? Exactly. What is double free? Why are they dangerous? So we'll cover most of those things. We have explained most of them already, right? So, but we'll still talk about them in more detail. So for now, let's work on learning how to work within Rust ownership system. Now, for the few minutes we have left, let's see examples of how ownership works in Rust. Now, remember I explained the other time that the ownership simply means that is a literal term of I own this until I have this. Do you get now? So it simply means I own this, then I have this. That's just a minute. So whoever owns, let's say for instance now, I have something like this. Okay, yeah, let's start from here. In Rust, each value has an owner, statically determined at compile time. There is only one owner for each value at a given time. Now, let's look at the move semantics. Now, ownership can be transferred. Yes, that's one thing you should know. Now, let's look at an example. If I have something like let A equals to hello world, like this. Now, currently, now who owns hello world here? This hello world, it is variable A, right? A is the one that owns hello world. Now, you can send this hello world to B. You can do that. But currently, at this point, A owns hello world. This A here owns this variable. So at this point now, hello world belongs to A, basically. But now let's look at B. Now, this B here now owns A. So that means automatically, because you've assigned B A to B, that means B owns what? Hello world. Do you get now? Now, don't worry, you'll see more examples. So, but then try to understand this simple one is very important. A owns a word, right? Now, but you assign A to B here. So that means A is a word. So Rust ownership system is baked into the type system. Each function has to determine the signature and how to interact with its arguments. Now, so far, all of our methods and functions have consumed the argument. They've taken ownership of them, for example, this. So it simply means that you have taken ownership. So why this was showing error the other time, we are going to come back to it. Now, we might not do that today because of time. I don't think we can explain everything I wish to explain here because of time. So we might not even finish with ownership. But what's important to know is that Kushimo, yeah, Bashir, go ahead.
All right. You talked about that damage collector initially.
Yes.
I don't know. How do Rust handle that? Is it that after the program is being run, the memory is being cleared automatically in Rust?
Okay, so we said it does not have a garbage collector at runtime, right? So that means all of the things that it should need to collect in terms of things like unused memories and all of those things, it will already tell you before running the program. So at runtime means that this is how other programming languages does it. So maybe you get an idea. Now, when I run my program, say I have something like this. Let me give you an instance. Let me write a simple program from terminal and try to show you something. Now, you can see this, right? So let's say I have a Node.js application, right? So I define it like this. Let's say I have a variable. So I have a function. Right, in this function now I return now this is the function. Let's say this is the whole program, right? So if I call one like this, what does it return? Mayowa. But look at let's say this is the beginning of the program and the end of the program. That's all. So in this program now, I have a variable that I'm not using here called what? Name. In this case, nothing tells me I'm not using the name. It will not even affect me. Now this is a garbage to the compiler because you are not using it. It's unused memory. It's unused space. But it has already allocated it to name. And this memory now is taking like let's say 8 bits in memory. It cannot seem as much to you, but it's much to the compiler, it's much to the program, it's much to the computer itself, it's much to the program you are compiling to run as a standalone application. So in this case now, this is already a garbage. So at runtime, when you are running this application, let's say you've packaged it and everything, you run this application, this becomes a problem. Not really a problem for the compiler because it's just one. The compiler knows how to optimize and say, oh, this is not used and delete it. But those things happen when you are running the program. You get now. But in Rust, those things already happen even before you run the program. Do you get now? So you don't even need to get to runtime to see these things. So that means Rust will not run if you have something like this. Okay, it will tell you right? That you have unused variables. Do you get now? But most times now, you know that automatically you can't have this pass. You will not even allow you will know that okay, this does not happen. So it does not have a garbage collector. It simply means that it's going to already manage all of these things before even runtime. So it doesn't need to manage all of these things for you. So that means all the extra work the compiler will do to run this kind of program for you to like delete it, and because before you can delete it, you need to first check if you are not using it in the code. So you need to first go through the code, check all of the grammar that is defined and check it's not used anywhere. So that means if it's already assigned, right? This is assigned, but it's not being used. So it already knows. So the compiler will now make the decision to either delete it or leave it. Now all of those decision making is extra work. It costs time. Do you get now? So that's why programs are faster and slower than each other. I mean, because there's no garbage collector for us, it makes it faster because it doesn't need to do all of those checks of is this variable assigned or not. He already knows. He already knows if it's not assigned. He already knows if it's assigned because that's part of the program structure. That's what program syntax and semantics. So he already knows if it is assigned or not. You get, so even before runtime. So that's why they say there's no runtime. Remember they say there's no runtime garbage collector. So there's no runtime garbage collector. You know all of those things even before runtime. He tells you. Do you get?
Yeah, I get. Thank you.
All right. So so now let's move on to the ownership. Let's just take a bit of simple examples of ownership before we do more with the other ones. So now the first thing to do is let's look at this example. We already talked about this, right? You pass in hello world to A, so that means A owns hello world. Now B, now you have moved A to B. Do you get now? You have moved A to B. So now let's see something. Let me show you an example just to make it clear. So let's say we have a variable called, let me do that before the struct. So let's say I have A equal to hello world dot into something like this. Now, and I say let B equal to A, right? Now let's say print line the value of A is A, right? Now you can see that there's something here. What's the error here automatically? So complaining of the type. Okay, let me convert this to string. Yeah, okay. Now you can see the error. This is the error I want you to see. Now you can see there's an error here. And what's the error here? You can see. Please try to follow along with this. So this is the ownership thing we've already started it. Ownership, borrow checker, ownership, you work hand in hand. So once you understand one, you understand the other. So borrow, so look at the thing here. So now let's try to analyze this. What's the error you see? Borrow of moved value A. Value borrowed here after move. Do you see this now? It's saying that what value of A was borrowed after moving it. Now what does this mean? Now let's go back to our code. We'll still come back to read the error. Now the first thing we did here was A was assigned to what? Hello world, right? We already established that. But that's not the only thing we did. We moved A here. Where did we move it to? We moved it to B. Please try to follow this. So we moved A here to what? To B. Where did we move it to? We moved it here. Do you see it now? We moved A here. We moved it to what? To B. This is B. So we move the value of A that we have here. We move it inside B. Do you get now? And then the value that we have already moved it, right? Now remember the rules that we checked. Let me go back to the rule before we continue. It says what? Data is never mutated while it is being read. Data is never read while it is being mutated. Data is never accessed after it has been destroyed. Now, it means that after moving A to B, does A still exist? That's the next question. Please, I'm following this thing. Like, this is very important. This is the basics, but then it's very, very important for ownership. Now, I have A here. I move A here at this point. Okay. Now, please try to follow. Try to follow this. Just follow this example, just this one alone. Once you understand this, it will get clearer to you. Now I have A and I assign a string of what? Hello world to A. You understand this, right? Everybody gets that part. It's just you're assigning a variable, right? Musa, did you get it? Please, I want you to follow now.
Yes, yes, yes.
Okay. So that's the first thing. Now, after assigning value of hello world to A, right? So who owns hello world now? Musa, that question is for you, please.
Hey, hello, can you hear me?
Yeah, I can hear you.
Let's say the first one, the first wave declaration, A owns the other one.
Okay, so A owns hello world now. So at this point now, what am I doing secondly here? I have B, right? I assign A to B, right? That's what I'm
Okay.
doing at the time. Now, so now I have B defined here, right? Now this B here is a variable. But what am I assigning to B? I'm assigning A to B, right?
Okay.
So now, this case, what does this mean? It means that this value of A now, who owns it now? Who owns A? Who owns this here? A owns it, right? Now, who owns A here?
You say you are assigning to the thing they own it, right?
That means B owns A, right? And B automatically owns hello world here.
Yes.
Exactly. Now, in this case now, in the normal sense, let's look at the JavaScript equivalent. Now, let me show you something. Now, please try to follow this. So, from this code I wrote here the other time, let me do the same thing. A equals to what? Let me say A equals to string. Let me write it inside TypeScript so it looks similar to the Rust. So, A equals to string and hello world, right? Like this. Oh, sorry. I forgot I'm writing the terminal. Okay, so we have A like this. So let's say we have B equal to A like this, right? Now, let's say I now print console.log rather. Value of A is sorry. Say the value of A is A like this. Now, will I still get the value of A here? See, I still get the value of A even after passing it to what B. Now let's see another thing. The value of B is also what? Hello world. No, sorry, let me change this to B. I don't know if you get what is happening here. Now in JavaScript, like look at I'll try to explain the both of them now. Now in JavaScript, I do the same thing as what I have in my Rust program. Now look at my Rust program. It's very similar to what I have. In my Rust program here, I have let's A equals to string and hello world, right? To string. In my JavaScript program, I have same thing. A equals to hello world, B equals to A. But in this case, if I print the value of A, what do I get? Hello world. If I print the value of B, what do I get? I still get hello world. But in my Rust program, right, if I print the value of A, you can see that there's an error already. It's already failing. It will never run. But if I print the value of B, like this now, okay, B is fine, you can see, but A is still throwing an error. Now, why is these two things different? Why are the two programming languages doing things differently? Now, that is where Rust ownership principle comes in. Now, you already understand that this belongs to this. LOL belongs to A, and A belongs to B. So that means B owns A. Now, what I'm not trying to do is, I've already moved the value of this inside B, and I'm trying to reference it again at this point, which is not possible. Rust will not allow me. Now, if you're familiar with other languages, you'll be like, why? It's normal now, right? That's the idea. That's why I'm using this JavaScript to explain. It will work in other languages. It will work in Python. It will work in JavaScript. It will work in almost every language that you can think of. But it will not work in Rust. Because Rust is trying to make you understand that you have already moved this value to B. You do not have ability or access to do it here again, except you are copying the value instead of moving the value. So by default, when you assign a value, what are you doing? You are moving the value. I don't know if this is clear to you, Musa, or any of you that person on the call, please. Do you understand the analogy? Okay, because this is important. I need you guys feedback. Okay. So because this is very, very extremely important at this point. Like you guys need to understand this. Understanding this is like a crucial part of what you want to do. Like really. So now, okay. So okay, yes. Very good.
Yeah, hello, can you hear me?
Yeah, I can hear you. Right.
Yeah, so I just have a question, and my question is: so does it mean that after moving the value of A to B, does it mean that the memory where the value of A was initially stored is, cleaned or something?
Yes, at this point, Rust will automatically manage this memory allocation for you because in this case now, what it did is it moved the value here to this place. So the memory has been moved also.
So completely A becomes non-existent.
Exactly. It becomes non-existent. So that's why you see this error here. Now let's come back to the error because I said we are going to read it again. So in this case now, you say borrow of moved value. So value borrowed here after move. Now error originated from macro call, value moved here. Move occurs because A has type string, which does not implement the copy trait. Now, consider cloning the value if the performance cost is acceptable using dot clone. So that it will tell you what to do, to tell you how to go about it, how to implement all of those things. Do you get? So in this case now, the simple reason is because the memory slot where excuse me, where A was assigned before, right, has been automatically moved to this thing. So it does not exist here. So the compiler knows not where to find it anymore. And because the compiler does not know where to find A, it has to throw the error. So Shaibu, does that answer your question? So that is exactly what it is. So the whole garbage collection thing, the whole ownership thing, this is the basics of it. If you understand this well, it's the basis for every form of ownership that we'll talk about here.
Yes, sir.
Yeah, I can hear you.
So, I have a question. Like,
Oh,
after this now, it means that E has been destroyed, right?
yes.
So, can we now redeclare A after moving? Can we redeclare another variable called A after transferring ownership to B? No, like after the yeah,
Like this. Do you mean like this?
yes, something like this.
Yeah,
If
we
you've
can do
already transferred the ownership.
yeah, we can do this. Remember that we said that there's something called shadowing the other time when we talked about like 3 weeks ago. We talked about shadowing of variables. So we can perfectly do this. This is fine. And you can see that the error is not there again, if you notice.
Yeah.
So we can do this too. Like we can do this. Why? Because this is entirely a new variable. It has nothing to do with this one. Do you get? So but if you move this down here, it will still throw the error. Why? Because this A exists before this one. Do you get now? So the ownership principle is just that when you have already moved certain data types that do not implement. Now remember, there's one important thing I need to point out. That's why I say we'll come back to read it. If you look at this, it says something about move occurs because A has type string, which does not implement the copy trait. Now I know we've not talked about trait, right? Trait is a very important topic. We are going to talk about it. We need to even talk about it because you need to understand traits. There are certain things we have seen. Remember last week when we talked about the modules. Remember I mentioned traits. I don't know if you guys remember the not pub, the derived traits. Right, we talked about derived traits. Let me see if I still have that open here. Okay, I do. So let's go to this. You can see this derived now. Do you get now? We are deriving this. This is a trait. So what this means is that why you see this error here is that it's saying that A has type string which does not implement the copy trait. So it means that this guy here, this is a string type, and string type does not implement copy trait. So if you want to, excuse me, if you want to use it, you need to use clone. That's why it's giving you option. Consider you cloning the value if the performance cost is acceptable. So that means cloning is more expensive than moving objects. So that means copying objects is more expensive than moving. Now, all of these things will introduce you to certain concepts that you do not know existed in your programs. If you are familiar with things like JavaScript, wherever you write code, or Python, or most high-level languages, you will not even know this thing exists. Why? Because there's a lot of abstractions that those languages do for you. You just write, you pass variable, blah, 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 and then you are done. But you don't know what goes behind the scene. You don't know how to optimize your code like perfectly. And those things will teach you how to do it. Like Rust will teach you. That's why it will change your mindset on how you write your code before, to give you a better way to perceive and to write your code. So you begin to write code in a professional way by default. Even if you want to do, like for instance, now when I'm writing front end now, there are certain things I look out for that, because I understand how Rust works, it kind of like just setting. Even if I'm writing things like, let's say I'm writing Solidity, for instance, or like, any other program language. Let's say I'm writing JavaScript for backend too. It doesn't matter whatever I'm doing. I tend to use this principle to now follow what I'm working on. Why? Because I understand that when I'm writing, there are things I don't want to make mistake on. I don't want to declare a variable I'm not using. That's one. Like, it's inbuilt now in my head. I don't use it. I don't declare a variable until I absolutely need it. That's one. I tend to make my code as modular as possible. That one will teach you how to do that, because then you want to have certain things to import. You want to have those things structured. Structure is very important for your program. And that's another thing to understand. Another thing you want to understand is that because this does not allow you to, you understand that you move, it's good for you to, like, moving data is faster than copying data. So as much as possible, when you need to move data, you just know that, this is what I want to do. And by the time you do it, practice, it becomes a part of you. You begin to write code in such a way that people will like your code. Your code will seem like it's faster than other type of code, just because of the way you've written it. It might not seem like much, but by the time it compounds, it makes a lot of sense. The way you naturally write your code, the way you actually see problems, and like the way you see the problem, the way you implement a solution, will be different from the person that doesn't understand this level things. And that's one of the things. That's why I keep telling you guys from the beginning of the class that you need to change the way you think about programming in general. Because to teach you the right way, it will definitely teach you the right way to write code. So you tend to understand some things, some low level things, like how you can do it. And from there, you begin to understand how to extend your own programs in high level language. If you want to write a library in JavaScript, how to extend the proto library, or you want to extend the default standard library in Python to, maybe you have a large project you're working on. You can extend the standard library, maybe string library, the integer library, make it typed, make it not to accept some things you should not accept. You can do a lot of things that you naturally will be looking at. Well, how did they do this before? But then you just see this and you're like, oh, I know how they do it. It just makes sense. So that's the idea. So it's good to have an idea of these things. It's good to understand how they work. It's good to understand that they do certain things, they cover certain areas, and you build on those knowledge, right? And then now you can see how this works. Now you can see that move is faster than copy. Now that's a very, very important thing to know in any programming language. They might not tell you, but it's true. It's happens in any other language too. Move is faster than copy, because you need to clone first of all. You first duplicate the memory to allocate another memory first, and then start managing two memory spaces. But then if you just move, you're not managing anything. You just copy the memory. You just move it from where it is and move it to another place entirely, and that's all. It's a one-step process. Copy is a two-step process, 2 or 3-step process. So you see that it's faster. So then this will help you understand that, oh, okay, now I know why. So those are the little things that makes some programming languages more acceptable than others. Like Java now. Java tends to manage a lot of those stuffs for you too. It's faster, it's this and that. It's more strict. It's this, just same way as Rust is strict. So there's a lot of things going on, and this is where you guys begin your actual journey into like proper low level Rust program. Now that we've started ownership, by the time you talk about ownership, we talk about Spark, heap, reference, destructors. By the time we cover all of this before going to traits, by the time you guys get to this point, I just pray you guys won't be as confused as I pray you won't be confused as at all. Because if you can understand all of the topics we have here, then you can be very sure that yes, you are becoming far more understanding of this. Bashir, yeah, go ahead. Yes.
Yeah, thank you very much. So concerning the ownership, so now
Yep.
that the value of A has been like transferred to B based on the fact
Yep.
that B is like the ownership. So is there a way to like create a, let me say, a copy of A whereby A will still like retain its value while B will also have the same value? Oh, okay. Oh, the clone.
Yes. You see what I wrote, right?
Okay.
So we can clone it. So I can see the moment I clone it, this doesn't throw an error anymore. But that's why, remember from the error message, let me show you the error again. It says consider cloning the value if the performance cost is acceptable. So that means all I will do is instead of moving, so if I put dot clone here, you can see that clone is also a method, right? That exists on the string. Do you get? So I can see that what does it pass? Let me show you something. You can see this. It says function of reference to self, return self. So it returns a copy of the value. Do you see it now? So if I have a value like hello like this, which is a string. String implements clone. That's ampersand str implements clone. So assert equal to this is equal to this. So now the difference is that when I implement something like this, see this implements clone trace. Right. So if I say let's d equal to c, right, and then I print. Let me leave this out so you can see the error. See, and then I save this. This way. Now you can see that C doesn't give me any error. You can see that it's similar to A and B. You can see this. This is similar to this. Don't worry, we'll talk about this next week. I don't want to talk about it now because of time. I want us to just end the class for now. But these are, but just know that if you want to clone, right, just we use this. But just try to, in case I forget and I don't touch this when we start the class next week, please point me to it that we need to talk about this because the data types matter. Do you get? Data types matter? So when we'll talk about traits. We'll talk about traits in detail later on. But we need to finish with some important things like ownership, borrow checker, borrow, and ownership. Those are two very important concepts. Now, what we have done here is that we have moved. In this case now, where we clone, it is called borrowing. We are borrowing the value. We are not we are not moving the value. Right. So this has ownership of the value, but this is borrowing ownership of the value. So that's just basically what it means. You borrow, you own. You borrow, you own. It's a very simple concept. But then, if you don't understand it, if the explanation is not given in a proper way, you will get confused. But that's just what. So with these two examples, you can literally understand ownership and borrow principle in Rust. So this is ownership. This is borrow, right? But if you remove the clone, if I do something like this now, if I do something like this is borrow, this is borrow, this is ownership, this is borrow, this is ownership. Do you get? So I own the value now, but here I'm borrowing the value. That's the meaning. Does that make sense? Don't worry, we'll talk about it next week again because we need to. I feel like today is not enough to talk about it because time is gone. I need to jump on another thing now. But then, this is just what it means. So this is borrowed, this is owned. B owns A here, but B borrows A here. That's the meaning. So that's the whole idea about the concept of borrowership and ownership. Like that's just it. Once you understand this, you will understand for more complex cases, it will make sense to you. You get? It makes sense to you. So yeah, that is it. So yes, thank you guys. Hope you understand everything we've covered today. Like hope everything is clear. I know there's a lot of information every week now. Like it keeps getting bigger and bigger and bigger. Yeah, which is important. So it simply means you guys are learning more. Right. But like I said, we'll still keep going back to it once in a while. We can't push everything once and not go back. We will definitely go back to it. But it's important for you to know the important concepts, the unique things, the concept of, and I'm happy that we're entering the most juicy part of it, the ownership, the traits, right? When we get to traits, you guys will start liking Rust well. Especially when we start dealing with ticket version 2, and you guys will enjoy it. You guys will enjoy it, trust me. It will make more sense to you. So yeah, that's it for now. Right. It's not an easy journey, but it's very interesting if you see someone that makes it easy for you. And that's why I'm trying my best as much as possible. I hope it is, at least I'm trying to make it easy. So if it's not, please let me know. Give your feedback. let us know how we can improve. But then, yeah, so that's it. So I'm just very happy that you guys have understood this basic scenario, which is this. So as hard as it may seem, and people will talk about it, is difficult. You can see that it's not. This is borrow. This is ownership. Like that's just the concept. That is just it. You understand these two, you are good. So yes,
Yes,
thank you
sir.
so much. Thank you. Yeah, do you have a question, Musa?
Yeah, I can you hear me.
Yes.
Just
This is asking
a
us.
game on LinkedIn. I could not access your Twitter DM. Then I DM you on
Oh,
LinkedIn.
okay. Oh, sure. Sorry, I told you I was not feeling like too fine over the weekend or something. Like last week, I've just been
But
kind of down. Yeah, so I've not really been like online. Even on Twitter, I've not posted anything much throughout last week. I've just been managing it even till today. But yeah, I'll respond to you on LinkedIn. And for see my number, this is my number, right? Let me drop my number here so you guys can drop me a message. 581 488. So this is my number, Nigerian number, Nigeria 234. This is my phone number. So please, you can drop me a message anytime. Feel free. Drop me a message. Personal, just drop me a personal message. Let me use from the class. I will know how to respond to you. So yeah, do this. So for the assignment, right? When will you start giving assignment? Don't worry, I'll start giving you guys assignment. Like very soon. But I want you guys to cover, I want us to cover up to like some, okay, don't worry, maybe from next week. I feel like once we cover what I want us to cover next week in terms of ownership, I'll just pick some exercises that I feel like you guys can handle now based on everything we've done. Then we have assignments, we have like it's much more than assignment. Don't worry, I have structures for that. So, to be like assignment, whoever wins get a prize, all of those things. We'll do those things eventually. It's in the works. We are planning it. So we'll do all those things. So we start giving all of those things to assignment exercises. We start giving you guys shout outs for those that have done it and all of those things. Yes, and we plan to make it like very structured. Just that, like I said, I don't want to start some structure. I don't want to overwhelm myself with the entire structure. Right, I will need you guys help in this time, and I will inform you guys how you guys can help with it also. So yes, that will be it. So I'll communicate it with you guys eventually. So that'll be that. But please, last week video, please don't understand modules. Go and watch it again. This week, please, I'll drop it today. I want to make the video live classes so that it can be easy to just go online. But then before that can happen, I want to put some things in place on the channel first so that it will be going to the YouTube channel directly. Then there won't be any issues. So that is that. So but this video for today, I'll try to release it today. In fact, today, maybe before the next 3 hours, it should be ready. The other ones always come late, but today's one should come early. Um, so that's that. So yes, that'll be all for today's class, guys. Thank you so very much. Please try to recap these things. If you don't understand anything, like I said, drop me a message. I know that our WhatsApp group needs to be there, but like I said, I'll need you guys' help with those things. I don't want to like undo all of it for now. I don't have time to undo it, trust me. But then I'll need you guys' help. Let's say very soon. I'm working towards it. I'll communicate with you guys. You guys will also assist in making that possible so that everybody can benefit from this. And then we can have more people that wants to join. We can talk about it. People that are interested can then come from the group. We can have more structured plannings. So that will be done definitely. Yes. So please bear with us for now. And for the assignment to that one, definitely that one we have assignment we have project we have we definitely make that happen. And there'll be things for it, there'll be rewards for that too. I plan to do that. So just to give you guys a bit of boost. But yeah, so that would be it. Thank you so much. Yeah, thank you for today's class. Thank you for the questions and for making it enjoyable. So yes, that is Rust for you. Rust is not hard, like I always say. It's just the mentality you carry to it and the way it is introduced and laid out for you. So I hope I've been able to do justice to some important concepts and we plan to do more. So yes, that was it. All right, bye guys. See you in the next class. Enjoy the rest of your week. Bye.